Hey guys, it's Black and Purple Math and Ministry, and this is going to be the first video for the calculus content, so let's get started. So, for Fairfield University, we went over 61.5, and we're going to talk about the limits of a function. So, what is a limit? Well, let's try to think of this logic right here. Limits are usually related to population. If you learned in biology, we will study the population of bacteria and how that will exponentially grow. So in a population of bacteria within a closed jar at the time of t seconds and hours, initially there are 500 bacteria. But wait, there is some logic that we're going to build onto this. It starts at 500 bacteria, and you may think it's going to continue forever and ever and ever. But according to this graph, it's going to somehow rise, but then level off because there's a maximum carrying capacity to hold all those bacteria and to keep them alive without dying. So eventually, there'll be a maximum asymptote horizontally that we can never cross, but try to get to. So there is some kind of limit. But what limit? Well, the limit in its initial definition, or intuitive definition, suppose the function of x is a function of x defined when x is near a constant as c, but is except a constant, where we write in a formula form the limit is x to the c, which is also the function of x, to a number that we're going to try to get to, but we can't get to. As the limit of x approaches the c is L, we can make the values of the function of x abruptly close, very close to L, by restricting x to the sufficiently close to c on either side, but not this part right here, not equal to c. So you might be thinking, wait, whoa, what limit? What the? So right over here is an example problem of what we did. So we have this right here. We start at this point right here. We are going to rise and then, whoop, there's a problem. That hole right there. That hole means that you can't equal to that limit. But somehow, according to that graph, you continue on, they go straight up. So right there is the limit. The L is going to always be your Y. And your C going this way on the x-axis is going to be your x. So here's what really happened. The limit of the function of x as x goes to a limit, it goes to c. That c is going to be that dot, according to the x-axis. So right over here is a problem where you don't want to make a limit, because even though it goes up to here, it stops, but then it's way too far. Your math teacher will tell you how far she wants it to be close, and then we'll continue on. This is just the introductory part. So then we have a few more examples. That x, the limit of the function of x, where x is going to reach to 2, is going to equal 4. So once it goes here, where x is 2, whoop, stop. By that time the limit is reached, 4 is going to be your y value. For this part, we have a hole right there. It's the same logic. The limit of the function of x is 4 when x tries to get to 2. Then to some parts close to that dot, there's going to be more math later on. And in this part, you can't really do that because, like we said, your math teacher is going to tell you how far apart that they're going to be. And this is really, really far. Even though it applies a similar logic, since it's way too far and it's hard to determine literally, we're going to say the limit of the function of x, because it's way too far from each other, where x reaches 2, do does not really exist because it's way too far. So yeah, this is the introductory part for limits, for the calculus stuff. Yeah, and we actually finished our very first calculus video. I hope this video has helped you understand the introduction to limits. Thank you for watching Black and Purple Math and Ministry. Like and subscribe.